Here the diagonal matrix, and there are some more results which are related to diagonal matrix. I want to discuss these results here. Number one, we have seen it, and we have the diagonal matrix D. The determinant of this one is A into B into C, the same as we have in the diagonal matrix or upper triangular matrix or lower triangular matrix. We want to find D square. So this is simply equal to A square 0 0 0 B square 0 0 0 C square. Simply this is the result. If I want to find D inverse, so my D inverse is equal to 1 upon A 0 0 0 0 0 1 upon B and 0 0 0 1 upon C. So these are the results, some results related with the diagonal matrix. We have a theorem here. If A is n by n matrix, a square matrix of any size, then the followings are equivalent. Number one, then we can say here the determinant A of A is 0. When determinant of A is 0, A is not equal to 0, then we can say here number two, same, said A inverse exists. We have seen already this one. If this 0, A inverse does not exist. So we are having here number 3, A x equal to B has a unique solution, So that's the related, these three are equivalent, and we can say, and we say here number 4, if the A inverse exists, I will say A is invertible. So this is the case when determinant of A is not equal to 0. So here is a note. We are having here when determinant of A is equal to 0, then we say A is a singular matrix. A is singular matrix. And then with the system, homogeneous system X equal to B has non-trivial solutions. That is other than the 0 solutions. There's infinite number of non-trivial solutions. So these are the equivalent things that we are having here related with the determinant. If determinant 0 is singular matrix, and this is having a non-trivial solution. Now I give you some example. There we use the row operation to evaluate the determinant of given determinant. So we are given here this standard determinant A, B, C, D, E, F, G, G, H, I equal to 6. I want to find the value of this determinant. So we need to make the row operations. So row operations, we can interchange two rows. We can just take the transpose of that one. We can multiply row with the number, and we have just discussed this one. So I just want to transform this one in this form. So I know, so important thing is that don't solve it. I say think and solve it. You just look on a determinant, look on the problem and see what are the steps you need to solve that one. Final result is in your mind, and then you just make the step into mind and then go to your plan. So here I can see I want to bring this one on the top. So interchange these two. I get here, I interchange R2 and R3, and I'll get here this equal, because this must come to the last one. We get here G, H, I, this becomes the last row as here. I get here A, B, C, second row, and we get here D, E, F. When I interchange two rows, I'll get here minus sign. So now I want to bring this one on the top, so I can write here this again. I interchange row 1 and row 3, so I'll get here the row 1 become here A, B, C, row 2 become D, E, F, no change in row 3, G, H, I, but I was having a minus sign, and interchange two rows, I get here one more minus sign. So at here, this minus 1 become plus, and the value of the determinant is 6, so the result of this one is 6. So if I shift here 2 times, it means get 2 minus sign, so the result become plus. If shift 1 time, you get 1 minus sign, again shift this one, interchange these two, I get here 1 minus sign. This was example A. I take example B. One more example for this one, how we apply the row operation to get our result. So I'm having here in this example, we are having given the determinant. I want to find determinant of 3a, 3b, and 3c, and I'm having here minus d, minus c, minus f, and I can get here, this is 4g, 4h, and 4i. So in this determinant, I want to find a standard form, so that can I write the value of this one. I know I can take common from each row. I can take common 3 from this row, minus from this row, and from this 4 from this row. I take 3 common from the first row. I'll get here change in my first row. This is A, B, and C. Now I can take minus 1 common from the second row. I get here D, E, F. I take 4 common from the last row. I get here G, H, and I. So this gives me here minus 12. And the value of this determinant is 7. So I get the result as minus 84. So I change this one so that I can apply, not here 7, this is 6. And we can have here 6, and the result will be 72. So that's the result. Now we take another part of this one, this part C. In part C, we are having here determinant. We want to find A plus G. We are having H, B plus H, C plus I. I'm having here D, E, F, and I get here G, H, I. If you look on this determinant, I want to remove this one G, H, I, and G, H, and I. So I multiply row 3 by minus 1 and add to this one. When I multiply row with the number, add to another number, there is no change in the value of the determinant. So I say I have the row operation. Here the row operation is minus R3 plus R1. So minus G plus G will be G, minus H plus H will be H, minus I plus I will be 0. We get here minus G plus G, we get here A, minus H plus H, we get here B, minus I plus I, we get here C. I get here D, E, F, and get here G, H, and I. So the standard given value is equal to 6. So the value of this one is equal to 6. So this is my result. I take one more part of this example, is D, and we are having here the determinant given to us to find is minus 3a, minus 3b, minus 3c. I am having here D, E, and F, and the last row is G, minus 4D, H, minus 4E, and we having I, minus 4F. Now we see the row operation I need to make to bring in the standard form. Number 1, my standard form here is ABC. I have minus 3a, minus 3b. I might take minus 3 common from here, and here I'll get the value as A, B, and C. Now second row remain the same, no change. The third row we want to bring here G, H, and I. So we need to remove this. So we multiply second row by 4, R2 plus R3. We are allowed to do that one. We multiply row with the number, add to another row. There will be no change in the value of the determinant. We are allowed. There are 3 row operation. Interchange to row, minus sign. We take common from any row. The value of determinant multiply by the same row, same number. Take any number, and then multiply row with the number, add on the row, no change. So multiply 4, add to this one, we get here G, we get here H, we get here I. So this is minus 3. The value of this one is 6, and the result is equal to minus 18. So that's our solution. We're having a 5 by 5 matrix. We want to find determinant of that one, big one. But here we are asked to using the row operations. So again, as I said, before solving, think. I will add this one. Before solving, plan. Plan the steps. The things will be very easy. Row reductions mean we can multiply row, add to another row. We can interchange to rows. So these are allowed. But here, when we multiply row with the number, add to the row, there will be no change in the value of determinant. We interchange 2 consecutive row, we get here minus sign. Now look on this one. I want to change into the upper triangular form. Then I have the diagonal elements A11, A22, A33, A44, A5, 5. They'll give me the determinant. That's how we can solve it easily. So to do that one, these off diagonal elements are here we're having this minus 2 is off diagonal, this 2 is off diagonal, and this 1 is off diagonal. So it means I may need only 3 row operations to make this I diagonal 0. When off diagonal is 0, then my determinant is simple, a11, a22, a33, a44, a55. To make this one 0, we multiply row 2 minus plus 2 row 1 plus row 2, this will become 0. To make this one 0, I multiply row 3 by minus 2, minus 3 row 3 plus row 4, then this one will become 0. Now let me write the result. We get here 1, 3, 1, 5 and 3. Then multiply by 2, add to this one, we get here 0. Multiply by 2, add to this one, we get here minus 1. Multiply by 2, add to this one, we get here 2. Multiply by 2, add to this one, we get here 6. Multiply by 2, add to this one, we get here 8. So now we are having row 3 is no change, 0, 0, 1 and 0, 1. Row 4, we multiply here by minus 2, add to this one. So sorry, multiply by, here is not 3, this here is 2, minus 2. So multiply by minus 2, we get here 0, we get here 0. Multiply by minus 2, add to this one, we get here 0. Multiply by minus 2, add to this one, we get here 1. Multiply by minus 2, add to this one, we get here minus 1. Now, our last row will remain the same, 0, 0, 0, and get here 1 and 1. So the next which I want to make, this off diagonal element, is my here, this is here is 1. This I want to make this one 0. And I can just write again this whole of the determinant of A is equal to, so I'm having here the first row. My first row is 1, 3, 1, 5, 3. My second row is 0, minus 1, 2, 6, 8. And my third row is 0, 0, 1, 0, 1. My fourth row is 0, 0, 0, 1, and minus 1. To make this one 0, I get minus R4 plus R5. I get here 0, I get here 0, I get here 0. Multiply minus adding this one, this becomes 0. Multiply minus adding this one, this becomes 1 plus 1, 2. Now this is my upper triangular matrix. My determinant is equal to A11, A22, A33, A44, A55. So my result is equal to minus 2. The idea is that we can change any of the given determinant in the form of the upper triangular matrix, diagonal matrix, lower triangular matrix, which one is easier, and just multiply the diagonal elements, will you get the result.